This video is an introduction for people to work with data. And really the first thing to recognize is the devil is always in the details. The real goal is to turn raw data into information. And initially the raw data is usually just a column of numbers, which you can use Excel or Excel-based software very conveniently with to do the things you need to do. The first thing is you want to plot the data so you can look at it, adjust the zeros, adjust the gain or scale, define where is the baseline, and then define where the peak is, when it starts, and when it stops. So here's the result of just plotting the data. The next thing to do is don't believe the plot itself. Go look at the raw data and plot it without any extra lines being added to it so you can see that it's what you're looking at is real. The scale is pretty well adjusted so you see everything on the same page. When you blow it up a lot, you'll notice there's quite a discrepancy between the two sides of the peak. We'll deal with that later. So we look first at the front side. Say it looks like the baseline is drifting. And then look at the back side of the peak and you see it going way down and coming back up. So now you have these two different problems. When you try to assign peak start, it's either way back here or it's right near the peak. And depending on your approach, whether you assume no drift or a shift or just a constant drift through the whole run, it gives you different answers for where is peak start. And similarly, if you look at the other end of it, peak stop has the same kind of problem. What you think is peak stop depends on what you think the baseline is. Now, as you start to go further in the process, it gets even a little more interesting, and that is the quantitation aspect gets affected by your choices in peak start and peak stop. There are two common ways to deal with peaks. One is called the peak height method, and the other is the peak area or integration method. For the peak height method, you really need to get the maximum value. You have to find where the maximum of the peak is, and then you have to do an extrapolation process for baseline start, and baseline stop, peak start, and peak stop. And the reason you need the peak maximum location is you have to drop it perpendicular so you can get an accurate measurement of the peak height. Now, in the integration method, it's a little bit different. You just need a peak start and peak stop and make some assumptions concerning the baseline. And usually you test all of your various choices on the impact of the results that they have. So there are some other things to bring up. The generally problematic situations are baseline drift, which is pretty easy to correct for, either in hardware or in software. Baseline shift is a more difficult problem, and it usually indicates detector problems or a chromatography problem. Noise is either just random noise because your hardware either doesn't have ground or you're out of sensitivity, or your software isn't very good. Imperfect separations where peaks start to stick together, that's a real problem that you can adjust the results either in software or in hardware. More about that later. A lot of this material is covered in the DAC2Go website, which deals with all of this stuff specifically.